So let's look at this question here taken from the 2010 PJC Paper 2 question 12. So this is pretty okay. The weight of Y. So basically Yami cereal bar is normally issued with 120 minus K standard deviation of 10. So that's alright. And F fullness yada yada yada. So I'm just gonna write it down because they already defined for you. So basically this is okay given that Y is actually normal distribution of 120 minus K comma 10 square. And basically you are saying that Px is less than 80, Py is bigger than 150, right? So when you do the normal distribution graph, right, this is actually just 120 minus K, and since given that these both area are the same because 80 is here, 150 here, so hence by symmetry you can actually show that actually 120k 100k minus k is actually 80 plus 150 over 2 lah. So that's, I think that's okay. So basically this will give us 115, and hence k will just be 5. That's shown. Okay, so that's not too bad. Now the interesting bit is this: 5 Yummy cereal bars I choose. Find the probability that exactly one bar way lesser than the lower quartile. Alright, lower quartile. Lower quartile just means that is this is lower quartile. I will draw it out for you. 1 is where lower quartile, which is 0.25% lower quartile Q1, right? Then they say that exactly one bar way more than the median weight. So another one bar is actually way more than the median, which is this is a median weight. The median is the mean as well, so this is 0.5. Okay, so you have 3, right? You have 5 Yummy chosen for exactly one bar, or 5, right? So in other words, you have got 1, you choose 5, so part 2, you have got required probability, which is actually just probability, which is actually just 1 under 1 under Q1, and then 1 between 1 is actually bigger than mu, and then you have got 3, which is actually just between Q1 and mu, right? So this is 3 of it because it's 5. So in other words, you just remember to multiply with the arrangement, which you could select them, which is actually sorry, 5 factorial over 3 factorial. That's it. So you can calculator this lower quarter will be 1 quarter, middle, and then this will be 1 quarter about 3. 5 factorial over 3 factorial, which is actually just 5 over 128. That's about it. That's part 2. So find out probably that the weight of the mass to running tracer differs for 1/2 of the time of the weight of running tracer by almost. So the assumption needed for your working. Okay, great. So how do we do this? So part 3 is basically asking you to find 2 randomly chosen Yummy cereal bar differs from 1.5 times the weight of randomly chosen furnaces. So Y1, this is what you want, basically required probability is Y1 plus Y2 differs from 1.5 time weight by at most 5 gram. So 1.5 F by at most 5 gram. Okay, write this out, right? So that's what you want. So any y1 y2 just is for 5 points. So anyway, we're gonna get this as minus 5, and y1 plus y2 minus 1.5 f. Just make sure you know how to find your normal distribution and so on. So anyway, I'm just gonna write this at the side. Y1 plus y2 minus 1.5 f is normal distribution. What's my y1? Y1 1.5 f is actually given by normal distribution of 180 and 20, so that's okay. So basically if you want to find so this will be 2 times 115 minus 1.5, 180, that's okay, and 212 square plus 1.5 square, 20 square. Just make sure that you can find all these by heart, alright, which one needed to be square or not. So once you key in calculator already, you get this is actually 0.0582 3SF. The assumption would be assuming that the cereal bars, the mass of any cereal bar is independent of each other. Okay, it's just basically independent of other cereal bar, so that's okay. Part 4, what do we need? Part 4, find probably the relationship will cost more than 350. Okay, $2 per 100 gram. Okay, that's not too bad. So now the price, part 4, the price of F is given by 2 over 100 gram per F is in grams, right? 100 gram, yeah. So that's it. That's not too bad. So it will cost 350. This is 1. So in other words, this is a normal distribution of you actually don't need to do that. So you just need to find the required probability. Probability of 2/1 F bigger than 3.5, which is actually probability of F bigger than 175, which is equal to 0.59871, which is equal to 0.5 599. Okay, that's it. Part 5. Probably there are at least 55 but at most 65 bars with each costing 350 a random sample. Okay. It's a binomial distribution of randomly 100 bars. You can find probably there are at least 55 but at most 65 bars which costing more than 3.50. Okay, great. So basically define your binomial distribution. So let K be the number of cereal bar fullness cereal bars cost more than 350, or this all being out of 100 bars. Okay, so this is it. So K is binomial distribution of 100. Copied it 0.59. Use more SF is good. Right, it's a 1. Okay, so the required probability will be probability of 55 to K between 65. Okay, so this one you just remember you can actually just key this in calculator by changing it to K less than 54. This will be 0.73837. That's about it. That's how we do this question here.